Hi, this is Allison Warner, host of the Orthodontic Products Podcast. Before we get started with this episode, I wanted to welcome you to our new season and to let you know that if you previously subscribed to the MedCore Podcast Network to keep up with the latest episodes of this podcast, you can now find us and subscribe to this podcast on our standalone channel, simply Orthodontic Products. And now let's get to the episode. Hello, I'm Allison Warner, and this is the Orthodontic Products Podcast. Today I have with me Dr. Beom Kim, who is the Dr. Lyle Johnston Endowed Chair of Orthodontics and Program Director in the Orthodontic Department at the Center for Advanced Dental Education at the St. Louis University. For the last 3 years, Dr. Kim has led a research project testing direct 3D printed aligners, the findings of which were recently published in Progress in Orthodontics under the title Forced Profile Assessment of Direct Printed Aligners versus Thermoformed Aligners and the Effects of Non-Engaged Surface Patterns. Here's my conversation with Dr. Kim. Dr. Kim, thanks for joining me today.
Thank you. Thanks for having me.
Great. Well, so you and your team found that controlling material dimension, structure, and properties of aligners directly compared to thermoforming plastic sheets can make a difference when it comes to tooth movement. But first, can you talk about the difference between the different types of aligner materials that you were dealing with when you were working on this study?
So traditionally, whether you send in your aligner to the big companies or you're making your own in-house or in-office aligners, all the aligner has to be made thermoforming process. You have to make the model first, you have to print the model first, and then you suck down with the clear plastics and then cut it out to make the aligners. So we've been asking this question for a long time. Can we directly print the aligners? But in order to do this material has to be clear, transparent, that material has to be flexible, and also they have to be durable. And then most importantly, they have to be biocompatible. So these conditions are not very easy to meet. So many companies, they have tried to develop this types of material for a long time. And finally, about 3 years ago, one of the South Korean company named Graphy, they first introduced this material. So if you have a 3D printer, you can now directly print this aligner without having model, without going through the thermoforming process. So if you think about, okay, what would be the most benefit? Easily think about the benefit is probably you can save time and money because you or your assistant or lab person, they don't need to print the model and they don't need to go through the thermoforming process and then cut it out the liners and polishing and deliver to the patients. If you can directly print a liner, you can skip a lot of those unnecessary manufacturing process. So that could be a one big benefit. And the second benefit would be you can save a lot of plastic waste because you don't need to throw those model and think about all those plastic sheets after you're cutting out the liner. Those are has to be thrown away, so you can save a lot of plastic waste. However, the biggest advantage is a biomechanical advantage, which that we presented to this progress in orthodontics. Because when you make the thermoforming aligner, you cannot really control the thickness. Even though your thermoforming plastic sheet is the one uniform thickness, but after you going through the thermoforming process, the thickness of the aligner is different from the incisor edge to the gingival margin. So depending on the patient's crown length and the longer crown versus short clinical crown, the dimension is going to be all different. But the printed aligner, you can precisely control the thickness wherever you want. You can make it thicker one side, thinner on the other side. You can put patterns or you can make the bump inside. So that's the huge biomechanical advantage. So this study, we would like to test if we make it thicker to the specific area, can we apply more force or optimizing amount of force and also the minimizing the unwanted side effect. That's the concept we have, and then we did the test with this material. So it turned out, depending on whether you make it thicker or adding more thickness one way to the other side, you can optimizing uh, the force level that we would like to have, and also minimizing unwanted side effects. For example, biomechanical rules for fixed braces. If I want to bring the canine down, high canine on the upper canine down, if you're running the small nightie wires, then as a canine coming down, extrude, adjacent lateral incisor or first premolar will naturally tipping up. They will feel intrusive force because of action and counteractions. Okay? But whether this is going to happen in the clear aligner, this is we did not know actually. But it turned out we're using very sophisticated multi-axis real-time three-axis force and moment sensor to measure the force when we apply the aligner, which direction of force and then moment, not just amount, direction as well. We're gonna how the patient is gonna feel. So it turned out is the clear aligner biomechanics is much more complex or complicated than regular fixed braces case. That was the one of the other findings. So because of the you can control the thickness, you can control the geometry inside of the aligner. That will open up the huge opportunity for the orthodontist. Because one aspect is a lot of people, especially patients, they don't like attachment. Orthodontists, we don't like attachment to put it on, right? Nobody like attachment because the patient's expecting there's nothing. They just want a clear plastic. They expect absolutely nothing, but that's not the reality. You have to put attachment in order to achieve certain types of movement. So the ultimate question is how can we not using attachment, or can we at least minimize of using attachment? That was the ultimate goal. So by designing the aligner, instead of putting attachment, if you can make the internal bump, or a lot of people understand as a pressure spot, like in Invisalign. I don't want to mention the specific name of the company, but there is something is sticking out inside of the liner. If I can make it designed as a pressure bump or spot or pressure column, shaping in the certain direction, we might be able to reduce the number of usage of attachment. For example, if I want to rotate, if I make it bump one side and a slightly different angle than the opposite side, maybe we can create the rotational moment in order to rotate those canines or premolar. So that was one huge advantage. On top of it, if you think about the removable appliances for the class two functional appliances, you can design something on top of this printed aligner. Occlusal surfaces, you can make the twin block types of pattern. You can print them out while patients wearing them. They can correct a little bit of class two while they remove some of the crowding or closed spaces. So I think this just opened up the huge opportunity and has a big biomechanical advantage for, I guess, the scope of the clear aligner therapy. That's the super exciting about. Yeah.
Yeah. Well, and how, okay, so what are your thoughts on how close we are to orthodontists being able to implement this in their practice? How far away do you think we are from there?
So, in terms of the government regulations, they have FDA approved approval. Yeah, this year. So, if you want to use it for your patient, you can use it for safe. And there are a couple of studies they tested about the cytotoxic or safety about this material. They all turned out it's a pretty safe to use. And the European market, they were a little bit ahead of us. So there are multiple practitioners. They're actively using this material for patients. But in the United States, as far as I know, I'm the only person in the university setting and using it. And I have over 100 cases, either in treatment or finished the treatment now.
Okay. And then into, so what are you seeing in terms of treatment? How has it impacted your cases and your outcomes?
This particular material has a very interesting properties because they have is made out of shape memory polymer. Okay, it's almost act like a night tie wire. But the difference is in the night tie wire, you put it into the cold temperature, it becomes flexible or dead soft, and they heat it up to the body temperature, it steepens. So that's how we use a night tie wire. But this material has an opposite direction. So if you put it into the warm water or hot water, it becomes totally flexible. And then it goes, temperature goes down, it becomes hardened to move the teeth. So the how we can take advantage this characteristic is if you have adult patients, a lot of gingival recessions, a lot of undercuts, or patients have a long clinical crown, adult patient they want a clear aligner therapy, then they having a hard time to take the aligner in and out. I mean, that's very common. So that's the reason they give out with a little plastic kind of hook to grab it to remove the plastic. So from that aspect, when they heat it up, put the like a coffee temperature water, it becomes very flexible. So they put it into your mouth and then slowly increase the forces. So they have much more comfortable level of force. And also every time when we eat, we have to remove the aligner. So think about the plastic deformation. How many times patients will remove the aligner per day? Probably 10 times, 20 times, or maybe even more. Every time they do, they will introduce possible deformation of the aligners. But as you see, the plastic cup, Coke bottle, water bottle, basically, once you deform, they're not going back to their original shape. But this particular material, if they feel like they are not tightening, or at the end of the day before they go to bed, I recommend to put it into the hot water, warm water. It will go back to their original shape, so they can maintain uh, the better fitting for every day. And then the force level also the difference. So we tested the force level. Um, the ideal orthodontic force level should be around 100 to 150 grams of force, and some of the tipping intrusive force should be less than 100 grams of force. So when we tested with this, there is another study we published in the Progress in Orthodontics. Thermoforming aligner has way bigger, almost 10 times higher force than the printed aligner force. So, for example, zero point 0.3 millimeter activation trying to simulate extrusive movement, thermoforming aligner was 1,500 grams of force, 1,500, which is 10 times bigger than ideal level of force, but the printed aligner was 10 times smaller. So it's about 150 grams of force. So the force level is much more favorable, close to the physiological level of force based on this our study. So from that aspect, this has a gentle force for the patients and then lasts longer, and is much more suitable for the patient's comfort.
In terms of printing these aligners with this material, does the printer make a difference, or are we talking about kind of the standard printers that most orthodontists would have in their practice at this point, or is there a different type of technology that's needed?
I think this material has a photocurable, so um, all those different types of printers supposedly they should be able to print, but if they want to have an optimum result, obviously the car you have, you know there are variety of differences, right? So
Right.
for us as a university, we have three different types of printer. The Spring Ray Pro, which is we started for it works just fine, and then we also have a Asiga Max, which working fine. And then recently, about 6 months ago, we bought another 3D printer, Unis NB, which is slightly more expensive, but it's much faster, 3 times faster than existing printer. So we are using three, and if you already have a 3D printer and if you want to test it out, I would recommend to reach out to the manufacturer company for the graphic, ask them whether their existing printer is compatible or not. They tested multiple printers. They are listed on their website, but something very popular here is Spring Ray. I think that one is compatible. You can use that 3D printer. But I do like to mention you have to buy the separate curing machine because this particular material, when they need to cure, they have to block the oxygen. So we have a SpringRay Pro printer. We have a SpringRay Pro curing box. I tried to use that because I don't want to buy the new one, but it did not work because the oxygen presence in the atmospheric oxygen, they will combine to this molecule. They will penetrate into the structure. They will have different types of mechanical property, and also they will loosen up the cross networking structure. They will allow the water can absorb easier. So when you cure it, it looks clear from the beginning. But if you're not blocking the oxygen, a couple of days after the water gets in, it becomes cloudy and looks ugly. So you're not getting the same like the shape memory effect. So I would recommend to buy, if you want to use this one in your office, you have to use the oxygen generated, the specific curing boxes from from Graphy.
In terms of with the patients you're treating, have you changed your appointment intervals in any way with this material, or have you seen a change in kind of that treatment progress and how those appointments are structured?
Yes, the ideal. Um, if I go back to the fixed braces, we put a 14 night tie, put it in there. We want to leave it for 10 weeks or sometimes 12 weeks, hoping the canine is coming down and the teeth are aligned, right? But if I apply to the clear liners, we would like to put a bigger activation per liners. Some companies say you want to have 1 degree rotation per liners or 0.2 millimeter activation per liner. I would like to have a much bigger activation per liner. That will save us time and you can decrease the number of liners. But the reason why we cannot do that part is if I put, for example, zero point 0.5 millimeter activation per liner, the force level is just too much and patient cannot handle the pain and discomfort. That's the problem. So it almost compared to like a stainless steel wire. You can't put 1925 stainless steel wire from the initial bonding day. You have to use a flexible wire, right? So the biggest difference of this material is I can put much bigger activation per liner without creating the huge amount of activation force. So I'm constantly putting zero point 0.5 millimeter activations and even 5 degree rotation per liner, and then have patients wear just a little bit longer time, maybe 2 weeks, or sometimes go a little bit longer. So that's the big differences. For example, if you wanna your standardized activation amount is 0.25 millimeter activation. If you want to move 1 millimeter, you need four liners. But if I can put zero point 0.5 millimeter activation per liner, have them wear for 2 weeks, then I need only two liner. So that will cut half of the liners. So that's another advantage. Yes.
In terms of doing the setup when you're treatment planning, is there anything different from kind of from the clinician's perspective in terms of setting up the case on the computer or in the software to get it to the printer?
This is the most challenging area right now because most of the staging software, they're not designed for printed aligner. They're designed for thermoforming process. So I don't know exactly how far I can push the limit. Is it zero point 0.5 millimeter activation is enough? Can I go a little bit further? And what would be the ideal thickness of this aligner? I would like to make it thicker one side, thinner to the other side. I like to make the pressure bump. What dimension should I do? All these things are not 100% clear at this point, and none of the software had all this function. So I'm using ULab, and the ULab, they made a special software for us. I can make the shell, but their software is designed for thermoforming process. So if somebody come out with this direct printed aligner module for their staging software, if we can test it more streamline it, it would be much easier. But at this point, none of the software. So in the European side, they have a couple of software they already developed. So Onyx app from Germany, they have this functionality, and then Delta Phase and the company they have those kind of functionality. But at this point, if you want to use that, you may have to contact the graphic. They have their own software. So you make the stage model first, ULab, Archforms, or any other like a 3Shape software, create the stage model, and then you import those files into the graphic software. Then you should be able to create the shell, because you need to create the shell in order to print.
So, how do you think direct 3D printed aligners will change the industry and treatment in the next 5 years, 10 years?
I think it's going to change entire industry, because right now we have only one material, but I'm sure a lot of different companies working on it. As we have a better material and we actually optimize amount of activations and dimensions and shape and things like that, it has so much benefit compared to the thermoforming aligner. So I think in 5 years, maybe I'm just too bold, but probably 50% of the clear aligner patients will be using these types of technology.
Excellent. Well, another area of interest for you is retention, and you've been collaborating with Yote, a medical technology manufacturer, to test an on-site retainer bending machine. And you published early results in the study in the Angle Orthodontist in January 2022. What was your experience with this machine, and what did you find?
So different country they have a different preference in terms of the retainers. I know the European country they really like to use a fixed retainer, and I'm from South Korea. South Korea, all the orthodontists they like to use a fixed retainer, but in the United States, fixed retainer is not very probably preferable, because maybe it's a technique sensitive, and also maybe the oral hygiene could be an issue. So it's not as popular as the other country, but the typical process of the fixed retainer from the other country is they take an impression or they do the scan and then send that file to the lab and have the lab person to bend the wire and then deliver to the orthodontic office, and they will deliver to the patients. Obviously, it's time consuming and then also the expensive. So in the United States, a lot of people using just the chair side, very flimsy and flexible wire to put it on using the dental floss. But there are a lot of actually the case report uh, about unwanted activation. We took the wire, unwanted activation. So patients ended up having the severe consequences. The canine is root is coming up from the alveolar bone or something like that. There are lots of case reports. So many orthodontists just pray they would like to use it, but they just don't want something active wire with glue to the patients that you are ultimately reliable, right? So this technology is they bend the wire precisely, but if I manually bend the fixed retainer as a manual, I like to bend it in the same plane, but that's not possible because I'm using my finger. You're going to end it up introducing some of the torque. So if that activation is too heavy, eventually a couple of years after, teeth start to move, and then you're going to see the side effect. So this machine is, taking away those headache. They will do it for us, passively bend the wire in the one plane, so you're not introducing torque at all. So it's a pretty, I would say, the convenient appointment, comfortable appointment, because before that, you take the braces off and you clean everything, and then you dry it, and then try to fit the wire using the dental floss or holding it. If I holding too much, you activate the wire, right? So there will you will have some activate you will have those active force. They will possibly can introduce some of the tooth movement, but this one is you can bend it in the chair side within 5 minutes. So typical our process is before we confirm I'm going to take this bracket off this patient, we scan with the braces on. And then we put that file into their software. Then we can confirm what level I would like to make the fixed retainer. So make sure the lower teeth is not touching the upper incisor and things like that. Then we pre-banded the wire, which will take about 5 minutes, less than 5 minutes. So before we take the braces off, patients come back with the debone appointment. We glue them in first and then remove the older braces. So it's a very simple process and it's really, really precise and has a big benefit compared to chair side, whether you're passively bending or not. But the one very exciting feature with this company right now is we are developing finishing wire bending machine. So, the Sure Smile, if you want to back, individual banded wire, you scan the patient's teeth and then send it to the company. You have to wait until deliver the wire. But if you have the idea is you won't like to have an in-house machine, you scan the teeth. When you look at it, patients, as an orthodontist, I'm look at the teeth. Oh, I like to bring this bicuspid down half millimeter. I like to put the 7-degree tip. I like to put 10-degree torque. Even the very seasoned orthodontist, how there is no way we know precisely I can bend those wire precisely. So this machine, hopefully they can actually bend it for wire for us in chair side. So it's right now in works, and I'm expecting to receive the prototype by this fall, and then we're going to work on that to make it easier for the orthodontist.
Well, it seems like so much of your research focuses on digital innovations and how they're kind of simplifying things with orthodontists, but also customizing treatment for the patient. So, why do you think this customization is so important today?
You know, the the clinical skill for orthodontists used to be how precisely or fast you can bend the wire from the beginning. Then it is move on to how precisely I can put the bracket into the tooth. However, everybody is a different. Their tooth is different, different shape. Even the right and left side is different. So even the 3D printed customized bracket, you still have to bend the wires because everybody is a different. And we are not just, you go to the mall and buying a suit versus you have a customized, a tailor-made suit. They are totally different. So as our patients wanting to more, they would like to have a more precise or more better than just average treatment. So I think in order to reach the highest treatment goal, to make the patients happy and would like to make the highest quality of the orthodontic treatment result, I think the customization has to be done. And all the digital technology make us job easier. I don't think they're going to replace the orthodontist, but they will make us job easier for I can precisely prescribe this dimension, where, how much force. I think it's going to be the future.
Yeah. What excites you about the future of digital orthodontics?
A lot of people or scared about the AI, but I can tell you AI is not going to replace orthodontics because AI cannot make the judgment. They can make it average judgment. They can make us the setup much easier. However, there's a subtle differences and also the aesthetic part. We will not be replaced by AI. But from the other hand, all the things, maybe some tedious setup process or putting the bracket, it's going to make us so much comfortable and easier for us, all those digital technology. So we can see patients less, potentially with the remote, the monitoring, the tools and things like that, but still maintaining the highest quality of orthodontic results. So I think the future of orthodontic is bright And many young, and especially I have a lot of residents, wow, this is a saturated market and all things like that. But when we look at the population of the United States, how many people there getting braces, we are just scratching the surfaces only. And patients want to have better or more as they have a treatment in the adolescent, adult patient. They want to also the treatment. So yeah, future of orthodontics, I believe, is a bright.
Well, Dr. Kim, thank you so much for sharing your research and your thoughts on this. It'll be an exciting future, especially with all these new developments. So thank you.
Okay, thank you so much. Thank you so much for having me.
As always, thank you for joining us. Be sure to subscribe to the Orthodontic Products Podcast to keep up with the latest episodes, and be sure to check out orthodonticproductsonline.com to keep up with the latest industry news. Until next time, take care.